Thank you for joining us in exercise 3F. We're going to be looking at question 2a. And question 2 says find the modulus of each of the complex numbers in question 1. So let's go up to 1a and look at the complex number, and it's z equals negative 4i. Well, the modulus of a complex number is the distance that complex number is away from the origin if you have it in a two-dimensional plane. So if we have this as the real component of z, and here we have the imaginary component of z, and we're looking at negative 4. So if we go up 2, down 2, down 4, and we put, 0 is the real component, and negative 4, alright, here it is here, I'll just put it as a red dot there. That is the complex number. How far is it away from the origin? And the distance, you can see, is 4 units. Notice the modulus will never be negative because it's a distance, so be careful. The modulus is never negative. It's absolute. There is a formula that you have looked at, and they would say that the modulus of z, we use two vertical lines each side of our complex number to say the modulus of z is equal to the square root. And if you remember the distance formula of xy, it's square root of x squared plus y squared. So we'll be looking at the real component squared and the imaginary component of that complex number squared, and let's substitute. So it is the square root, and the real component of our z, as we said before, was 0. The imaginary component of this z is negative 4. So if you square 0 and square negative 4, you will get the sum of that, which is 16, and the square root of 16 is in fact 4. This is the positive square root of 16, and the answer is positive 4. And there we have the modulus. That's the distance that our complex number is from the origin on a two-dimensional argand plane, or argand diagram. I'll say argand diagram. I hope this has helped. Until next time, stay happy.